Okay, now we're going to look at absolute value inequalities. This is going to combine some of the information that sorry about the interruption. This is going to actually take us back to what we learned in our last lesson, and that has to do with solving our compound inequalities. If you remember, we talked about an OR compound inequality, which is actually called a disjunction, and we talked about an AND compound inequality, which is called a conjunction. So OR is called a disjunction, and AND is called a conjunction. Okay? So what we're going to do is we are going to solve some absolute value inequalities. So let's say that we have absolute value of 2x plus 1 is greater than 5. Now, if you have a greater than absolute value inequality, then what you're going to do is you're going to consider this a disjunction. It is an OR. So if you have greater than with absolute value, it's considered a disjunction or an OR. So we're going to write two sentences, and this is going to be very similar to what we just did. We're going to write 2x plus 1 is greater than positive 5. And remember that inside of the absolute value, it could be negative. So that means that 2x plus 1 could be, and now since I'm going to change this negative, I need to switch the symbol. Remember that from our last lesson as well. And then we're going to make this negative 5. So now we have two sentences that we need to actually solve. So if I solve the first one, I'm going to subtract the 1 and get 2x is greater than 4, and then divide by 2, so x is greater than 2. And then for the second one, I repeat my steps. So 2x, subtract the 1, and I get is less than negative 6, divide by 2, so x is less than negative 3. Okay, now we can graph these just like we learned in our last lesson. So we're going to put a negative 3 on here, and we're going to put an open circle, and we're going to shade to the left since it's less than. Then we're going to put a positive 2 with an open circle again because there's no equal to, and we're going to shade to the right on this one. All right, so let's look at another problem. In this problem, we're going to look at another absolute value with a greater than. So let's say we have absolute value of 4x plus 16 is greater than 8. This is kind of a combination of the previous problem with the absolute value equations and with the absolute value inequality. The first thing that you want to do is get the absolute value by itself. So we're going to have absolute value of 4x is greater than, and then a negative 8. Okay, so now we set it up as an OR, as a disjunction, as an OR inequality. So 4x is going to be greater than negative 8, or 4x is going to be less than, and we're going to change the sign, and it's going to be positive 8. And now I can solve. So I'm going to get x is greater than negative 2, or x is less than 2. Now, just to refresh your memory on interval notation, if you recall, x is greater than negative 2 can be rewritten as negative 2 to infinity, and x is less than 2 can be rewritten as negative infinity to positive 2. That's just to refresh your memory on that interval notation. Now, you can look at this on a number line and get those interval notations as well. So what we're going to do is we're going to put 0, and we're going to put negative 2, and we are greater than negative 2 with an open circle. And then we're going to put positive 2 and put an open circle, and we are less than. Now, if you notice, these overlap. This hasn't happened so far, so what does this mean? Well, this means that it could be one or it could be the other. And since they overlap, that means that the solution set is going to be all real numbers. Okay, let's look at another one, and in this time we are going to look at one where we have a less than. Let's say we have absolute value of 3x minus 9, whole thing divided by 2 is less than or equal to 12. The first thing that you want to do is get the absolute value by itself once again. And we talked about how to get a number out of the denominator. You're going to multiply both sides by what's in that denominator. And so that's going to give me absolute value of 3x minus 9 is less than or equal to 24. Now, since this is a less than symbol right here, less than or equal to actually, but since it's less than, it's going to be set up as an and compound inequality, which is a conjunction. And you're going to have to memorize these two things. So that means we're going to set this up as an and. What goes in the middle is my absolute value. So 3x minus 9 goes in the middle. And on either side, I'm going to put whatever symbol I have. In this case, it's less than or equal to. So it's either going to be less than or equal to on either side. And remember, we're making an and, which has 3 pieces. On the right-hand side, I'm going to put 24. And can you guess what we're going to put on the left-hand side? That's right, we're going to put a negative 24 over here because we're going to change the sign because absolute value can be positive or negative. And now we're simply going to solve this. So we are going to add 9 to all 3 places. Okay, and so that's going to give me a negative 15 is less than or equal to 3x is less than or equal to 33. And now we're going to divide by 3 in all 3 places. So that's going to give me negative 5 is less than or equal to x is less than or equal to 11. So on a number line, we would go, here's 0, we would go out to negative 5. And we're going to put a closed dot since there's an equal to. And then we go out to 11. Okay, extend my number line. Sorry, I didn't make it long enough. Here's 11. And put a closed dot there. And the solution set is everything in between. Now think about how we might write this in interval notation. We are including the 2 points, and it's everything in between. So you start from the left and go to the right. So that means it's negative 5 with a closed bracket since it's included, comma, and then an 11 with a bracket since it's included. So that's what the solution would be in interval notation. Okay, so to summarize, in order to solve an absolute value equation, you are going to set it equal to the positive or the negative after you isolate the absolute value. In order to solve an absolute value inequality with a greater than symbol, you're going to set it up as a disjunction or an or compound inequality. And in order to solve an absolute value inequality with a less than symbol, you're going to set it up as an and or a conjunction compound inequality. There is one last thing that I would like to mention, and that is what happens when you have absolute value of something and it is equal to something like this. For instance, absolute value of 2x equals negative 2. Since absolute value means the distance from the origin, that means that it's always going to be a positive value. So this is actually not possible, and it does not have a solution. I should say no solution, not solution. So this is no solution. Now this can happen when you're solving equations. It could also happen when you're solving inequalities. So you could see this with an inequality as well. So as you're solving your inequalities and your equations, make sure you look for situations that are not actually possible.